Come on up.
Thank you.
Yeah, it's great to have you here, Arati.
Hey, folks.
Thank you. Yeah, well, it's been a busy day already, as Todd and John mentioned.
It sounds like it.
Yes,
it sounds like a great kickoff.
Not every day you can start with a rocket launch, but you're involved with all sorts of things, including rocket launches and, self-driving cars and robotic arms and just a whole bunch of things. And so we're really glad to have you here to talk about what the Defense Advanced Research Projects Agency does, otherwise known as DARPA. And let's see if this thing will work. A friend of mine wrote a book one time called The Department of Mad Scientists, which was all about DARPA and the wild things that they're doing. And so I wanted to start out just with this mad scientist stereotype. Is that really what DARPA is all about?
Well, first of all, thank you very much for having me. This is just a great excuse to be in Seattle, and I'm really thrilled to tap into the tech community here, so this is great. Mad scientists, I like to tell people that we're actually mostly engineers and we're not angry at anyone, so that's not really a meme that resonates for us. And I'll tell you why. We have a blast doing what we do. I think we're privileged to get to do some of the most exciting and fun technical work on the planet. But at the same time, DARPA is a place that is, thank you, we are also serious as a heart attack, thank you, about our mission, and which we'll talk about, but it's breakthrough technologies for national security. And we're also really serious about all the implications of technology. We work on really powerful technologies, and we do it because we think it's going to advance national security in our country and the world, but we know that technology is always a double-edged sword. So I think, so I don't think it really resonates for those of us in the building, but it's a lot of fun for a book title, I guess.
Mm-hmm, mm-hmm. Well, when you think of someone who is working at the Pentagon about all the sorts of cutting-edge technologies that future warfighters are going to have, they don't picture someone like yourself and someone with a background like yourself. They picture some buzz-cut military guy, chomping on a cigar and directing these flying saucers around. So maybe you can tell me a little bit about how you approach the core mission of DARPA, which I assume is going to be helping our military and helping warfighters, and then how that translates into things that we might see on our streets one of these days.
Yeah, absolutely. DARPA's story began when Sputnik happened, and if you think about it, our country for maybe 15 years by then, post-World War II, had been building this research and development ecosystem with public funding for the National Institutes of Health and the National Science Foundation for Defense Research and Development, Army, Navy, Air Force. Really important backbone and foundation for the innovation that happens in our country, even today, 70 years later. But when Sputnik happened, people, it was a real shock that the first time humans put a satellite on orbit, it was Soviet humans that did that at the height of the Cold War. And that was a wake-up sign for the government and the Defense Department in particular to say, you need a place, in addition to all those other good things, you need a place whose day job is to come in every single day and think about technological surprise. And we were created to prevent that kind of surprise. The people who started DARPA very wisely understood that the only way you prevent that surprise is you go create surprises of your own. And that's what we've been doing for, now 6 decades. And when I talk to the people in the Defense Department or the military, the guys you're talking about, they don't all look like that, but we do have people with buzz cuts for sure. If you talk to them, they think of DARPA as the place from which stealth aircraft came and where precision strike came from. And those are very important military advances. They're the backbone of our conventional deterrent, even today. But in my Silicon Valley life, I found that the tech community generally thinks of DARPA as the place that, if you have a long memory, you know that material science came out of some very early research and investments we did to sort of create that field. Obviously, advances from MEMS to RF semiconductors, artificial intelligence, the internet. That's what people know about us. And And those are great examples. Every one of those was technologies that we pursued for our national security mission. We knew we couldn't build those amazing systems without that core technology. But then it was, it was the tech community, right? It was private entrepreneurs and companies and investors. They poured, probably trillions now of dollars into turning those core technologies. We lit that spark, but then a lot of private investment happened afterwards. And that's what changed. Those are the technologies that have not just changed how we fight, but how we live and work.
And one of the technologies that I was interested in was the Sea Hunter.
Yeah.
Now, some people talk about how cool self-driving cars might be, but you've got a frickin' self-driving ship.
We're working on it, exactly.
So is this something that's going to put sailors out of business, or why do you have these sorts of initiatives that go toward automation in warfighting?
Yeah, and we see it happening in our civilian lives. In the military, this is an example of a component of technology. What we're trying to do here is a ship that's sized to be able to go, weeks to months and sail not just, a few miles off the pier, but literally to leave the pier and navigate across open oceans, across thousands of nautical miles, and to be able to do that with very sparse supervisory control from back home. So a great deal of autonomies to be able to navigate. And so like the self-driving car, a lot of the core technical issues are about how do you avoid collisions and follow the rules of the road for the open oceans. And that's exactly what we're demonstrating now that this thing's Sea Hunter has been christened, it's in the water, we're working with the Navy to prove it out. Well, what does it all mean for the military? Today we have phenomenal capabilities on our Navy ships. Think about a destroyer, think about a huge number of precious souls who are on that ship making amazing things happen. And it can do a lot of different things. It can do everything that the Navy needs to, a huge number of the things that the Navy needs to do. But it is a very expensive way to operate. And it is dangerous to put those people at risk for missions like clearing mines in a harbor. And it's just an ungodly expensive way to do something like, for example, trailing after a quiet submarine. And those are the kinds of missions that this kind of unmanned vessel we think would be really terrific for. And so starting to, really the bigger thing that we're thinking about for military systems today is what are the architectures that get us away from just always relying on a big monolithic platform, a destroyer, an aircraft carrier, a fighter aircraft, a geosat, right? These are enormous systems. You cram everything onto them. They're phenomenally powerful, but they're pretty vulnerable because they're a point of capability. Can we start coming up with distributed architectures and teaming unmanned systems like this with highly sophisticated, staffed systems, and really fundamentally change the architecture of how we exert influence over vast tracts of the ocean or engage in air combat against a sophisticated peer adversary? Most fundamentally, how do we make sure that that moment doesn't come because our capabilities are so far ahead of what anyone else can do?
Well, I was going to ask whether you have to deal with questions about the Terminator and Skynet and the
all
ships
the time.
taking over, but what you just said is sending me in a different direction, just the whole idea of the lessons learned from the tech community. When you talk about more distributed resources, it really reminds, I'm sure it reminds tech audiences of what's going on with Uber and Airbnb and all these distributed networks that are displacing or disrupting what used to be a monolithic system. So especially for the techies around here, are there lessons learned from Silicon Valley?
Absolutely. And at the technical level, I think there are really important lessons to be learned. We engineers over decades have built phenomenally scalable distributed systems, right? Think about the internet. Think about the level of complexity we're able to design in an integrated circuit. So we know how to build layers of abstraction and build architectures that allow you to scale and have flexibility and to evolve. How you bring that thinking into military systems which, today if you peel the lid back on an advanced fighter jet, what you'll find is that the mission systems on that aircraft, the navigation system, the radar system, the communication system, the jamming system, the weapons control system, they have very tight real-time linkages that have to happen among them. They are hardwired together in this very complex spaghetti, both physically and in the software domain. And it makes for, again, powerful systems, but they're not flexible, they don't upgrade, they end up being stuck with old technology. They aren't going to give us the flexibility we need for the future. And so I want to be really careful that I don't think you can wave a magic wand and say, well, we'll just do it the way, the App Store works, because this is a different level of technical challenge. But we're working on some core technology for composability in those kinds of complex real-time systems that I think is going to be very powerful.
Mm-hmm. And I wanted to talk about another system because it kind of bridges the gap between automation and the hardware and the software. DARPA is working on unhackable helicopter, a little bird helicopter that is designed with a controlled system so that no hacker can get into it. So that really perked my ears up.
Yeah, that's a story that started a number of years ago when one of our program managers saw this wonderful research out of UC San Diego where, now I think people have read about cars being hacked, and there's been a lot of great work at the University of Washington right here. But at that time, that was the first time I think people had seen these kinds of research results where people were able to remotely get in and take over a speedometer. So there's this wonderful, iconic photograph of a speedometer. The car looks like it's going at 140 miles an hour, but it's still in park. And instead of saying fasten your seatbelts, it says pwned by Car Shark, which is just awesome. And that was a real heads up that embedded systems, this is really early in the IoT story, but embedded systems are happening. They're going to expand. They're going to be a much bigger part of our world. And if you are DoD, everything we do is embedded systems. And while they may feel isolated from the world, of course, they too are also connected to the world. And so we set out to do a program to ask the question, could we scale formal methods to start to build provably secure embedded systems?
And formal methods is a branch of mathematics.
Absolutely, and it has been used in formal verification, is used extensively in IC design, but now starting to, the question was, could you scale it for meaningful complexity of code, right? Not just a few lines of code, but big enough code to actually do something. And our first few successes with doing that were, with a little UAV. This little bird example is now the first time that we've recently been able to show it with, a system of some sophistication. And where this research is going is the idea that you could take the software for a system like a little bird or anything else, and essentially give it a cyber retrofit, jack it up and give it a cyber secure foundation with these approaches that give you provably secure software, provably secure against specified threats, right? So, it's not a magic pill, right? It's going to be about rigorously being able to keep out all the attack vectors you can think of. And then build the rest of the systems, the legacy systems back around it. And I know it's going to be important for DoD. I think it's going to be important in the IoT world as well.
Does it worry you that all of a sudden there's a big focus on the Internet of Things and that there's this corner of the Internet that DoD has been able to take advantage of with embedded systems, and all of a sudden hackers are going to see, hey, this IoT is a big thing, so let's put more of our nefarious effort into hacking into IoT?
The way I see it is IoT is just one more dimension of our information universe exploding. And the reason it keeps growing, it is so valuable, right? We keep adding applications, systems, more data, working in the cloud. We're going to do IoT. All of that is because of the huge value we get, whether it's military or commercial applications. And then, of course, with every one of those advances comes, more attack surface. And so this program that we were just talking about is a great example, but only one piece of many things that we're doing to try to turn the corner on cybersecurity. Right now, I think there's a sense that we're all chasing along behind the explosion in the problem. We think there's some ways, and provably secure embedded systems is a part of that, to try to get ahead of that.
And in fact, some of the challenges that DARPA has put on in recent times have to do with cybersecurity. Maybe you can tell us a little bit about that.
We just did the Cyber Grand Challenge. Do you guys know about Capture the Flag? Who's in the community? Yeah. So Capture the Flag is basically a game that very sophisticated the hacker community plays. There's a big one every year at DEF CON, and we essentially built a version of that game that was only for machines. And so the teams that competed built automated systems that would look at code, would figure out where the flaws were, would develop patches, would identify vulnerabilities in the other machines' codes. And we flipped the switch a few weeks ago. It was the day before DEF CON that we did this in Las Vegas, and we flipped the switch. 7 machines turned on, and lo and behold, within a few minutes, they started finding flaws and patching them. Now, this is a game. It's a smaller universe than the real universe of cyber that we all live in. But it was amazing to see they were able to find even flaws we had not planned on planting for them. They were able to find and patch flaws within minutes, the kinds of flaws that typically take expert human teams, many, many hours. They don't have nearly the sophistication of the most sophisticated human teams, but you can very quickly see that they start giving you a way to start scaling cyber, which I think is, that's the core point.
So that was a competition. Were there cash prizes with that? So
absolutely.
How much could you win by?
I think the winner got $2 million, and second place I think was $1 million and maybe $750. Don't quote me on those numbers, but it was something in that range.
But it illustrates
cool.
that DARPA is willing to put some resources into competition, and that's the way that DARPA has been for more than a decade. I remember the Grand Challenge, which was pioneering self-driving cars, and people at the time said, wow, that is going to be, amazing if that ever happens. And here it's happening. So that illustrates how incentive prizes from DARPA really have promoted not only technologies with military applications. For example, this started out as an idea for resupplying the front line without putting American lives at risk so much, but it really has translated into civilian technologies as well. Yeah. So are prizes going to continue to play a part in what DARPA
absolutely. Does? Just to back up a step, DARPA is about a $3 billion a year agency. All those dollars go out into the technical community to do specific projects and programs that we think are, have the opportunity to, they're high risk, high technical risk, but if they work, they can really change the future. That's what we're all about. In about a decade, a little bit more, a number of years ago now, Congress gave us new legislation that said, well, in addition to doing contracts and grants, if you want, you can do prize competitions and throw out an enormously hard challenge and have a purse at the end for the winners. And the first few challenges were about self-driving cars. This is the second challenge, actually, in 2005 that's up on the screen. At the first one, 0 competitors were able to complete the course. It was a little too hard, but amazing advances in AI, among other things, in between the first competition and the second competition made it actually possible for someone to finish this course with an automated vehicle in 2005. And I see those prize competitions as they are a wonderful complement to directly funding R&D, because when you have, as in this case, you've got a lot of the pieces of technology that might, if pulled together into a prototype, might be able to demonstrate something that wasn't possible before. That's a great moment to use prize competitions. And I'll just mention that our most recent prize competition, the next really big one that's coming up, is called the Spectrum Collaboration Challenge. And this one is about using AI in radio networks to have a competition where each of the teams they'll build radio networks that have embedded AI, but what they're going to compete to do is to maximize the amount of data that can be transmitted in a very finite amount of spectrum. there's a real world problem we all care about, right? But now if you think about, we have the front end of software-defined radios. Now if you add the AI-powered decision engine that lets you optimize what you're sending in a way that allows you to get your bits across, but also allows everyone else to operate, that's the point of the challenge. And it's going to be the first challenge where you get points not only for what you accomplish, but you actually get half points for what everyone else accomplishes.
Wow,
so it's
fascinating.
competition and collaboration. That'll be cool.
And we're talking about AI, which is a huge topic. At this summit, we'll have a panel a little bit later which focuses directly on artificial intelligence. And of course, Microsoft and a lot of other companies are talking about AI assistants, chatbots, that sort of thing. But that's something that's of interest to DARPA as well.
Yeah, I mean, AI is having this amazing second wave, right? I mean, we've been talking about AI for decades, but it's having this new era because of, essentially, I think, this era of statistical learning coming after sort of the era of expert systems, right? And we see huge applications in our national security world. This Spectrum example is a really great one. So we're using it to do things like domain-specific deep web search to allow law enforcement to go after human traffickers. We've actually helped them get indictments in that area, which is very satisfying to see happen. So some of those applications look like DoD or national security versions of what you see in the private sector environment. Some of them, like Spectrum, I think we're pulling it into completely new domains that are going to have implications for all of us, not just DoD. But I think the second part of the story is also, as powerful as this wave of AI is, it's also quite fundamentally limited. And I think that's, that tells us some important things about what the research agenda needs to be for the next wave that comes after statistical learning.
Right. That's a big theme, is that AI can be good at, for example, figuring out how to play the game of Go, but in terms of just conducting a conversation, I recently got an Amazon Echo, and it's pretty cool, but sometimes it just does not get the message. I'm trying to get something, and it just basically, it's the AI equivalent of throwing up its hands.
Yeah.
So.
Well, and these, like Siri before, these are amazing examples to me of both how far we've come and yet how far we really are from anything that's even remotely human, right? So they have great value already at this point.
So you've got an example. Let's see if we can get that up. Tell me a little bit about this, because this is obviously not a young boy.
Yeah, this is a little bit of a problem. So, I think the power of these statistical methods and image recognition, image identification, scene identification, those are great examples where we're seeing, and people here are among the companies and universities that are driving this area forward, so many of you know this deeply. But you also know that even when these systems get statistically better than humans at figuring out what's going on in a picture, they're not perfect, and when they make mistakes that no human would ever make. And this is a great example to me of the limitations of the current generation of technology. And when you see this, I think to me it underscores that we want to use this generation for all the things it's going to bring, but we also have to really be clear about what it's not going to be able to do. And this tells me, for example, in my world, if we're interested in navigating our self-driving ship based on statistical AI methods, or targeting and determining what a weapon is going to hit based on those methods, we have to take a step back and say, are we really ready to completely rely on a machine, knowing, even if it's statistically better than humans, knowing that its mistakes are not going to look like the mistakes that we live with already, that humans make. I think those are some of the questions I believe that are behind the adoption of fully self-driving cars. I mean, it's a very similar kind of thing. So one of the things we're doing about this, so when you see a problem, first you have to be realistic about today, but then at DARPA, we want to get on the research agenda that's going to drive the next era. So we just launched a program called Explainable AI, and its objective is to build systems. These systems, deep learning systems that generate results like this, are very, very capable, but they're sort of black boxes. When you go back and you say, well, why didn't you get an answer that makes human sense.
Right.
You see a bunch of weights, then what do you do? So the objective of our new program that's just getting off the ground is to build systems that give you that power of statistical learning, but also give you an explainable interface, a way for a human to know, well, oh, now I understand why the training led you to do this, and now I know how to fix it, or how far to trust it. I think those are going to be important conditions
So there are so
forward.
many organizations, we can talk about Amazon and Microsoft and Google working on AI and specifically natural language processing. So do you take in that information, or it sounds as if with explainable AI, you're taking your own course, which may lead to civilian spin-offs that those other companies are going to take advantage of? It sounds like it's a two-way street.
It's absolutely, it's this complete marvelous tapestry of interactions. So if you look at the natural language processing that is now the core of commercial products, and you peel back the layers, my first tour at DARPA was 86 to 93, and at that time we were doing a lot of the very early research that those people and those technologies. A lot more work has to come after that research before you get these awesome products, but that's how that, and then when we see those products, absolutely, we want to bring them in and use them for our applications as well.
And then there's another part to what DARPA is doing that has a big civilian spin-off, and we mentioned robotic arms, neuroprosthetics, things that are really going to help wounded warriors, but also wounded not warriors cope with everyday life. And so I know you want to talk about that, and I think you've got a video. Do you want to talk through that video?
Sure, we can do the video, yeah.
Okay.
Maybe just to set it up, one of the areas that we started working in a few years ago was neurotechnology. And this work really began because we had an amazing program manager, Jeff Ling. He was an Army doc, a neurointensivist. He came back from a couple of tours in theater, seeing the upper arm, the upper body injuries that our warriors have sustained. Lower limb prosthetics have gotten very good, but upper limb prosthetics until very recently have still been limited to a very simple hook. And he came back knowing we just had to do better. He started a program called Revolutionizing Prosthetics. I'm really excited that the first sort of simple product, it's very sophisticated compared to the hook, but it's simple compared to what I'm going to show you. That product is now entering the market, and it's essentially a complete arm. It's called the Luke arm, and it was developed by Dean Kamen's organization. And it's got all the degrees of freedom that my arm has. It weighs the same, and it allows you to start having a limb that operates in a way that starts resembling what you were able to do before. It's controlled by twitching your foot or moving a muscle in a residual limb. Jeff's a neuroscientist, though, so the other branch of his program was to understand signaling in the motor cortex, because what he's dreaming about still, we're still on that path, is how do you get near natural control by just thinking about moving a limb and having this mechanical robotic limb do what you have in mind. That means translating those neural codes in real time and fully integrating it with this mechanical device. So what I'm going to show you is a video that has, you'll see 4 people, and the first 2 are using their thoughts to control a mechanical arm, and the second 2 are receiving sensation back to their sensory cortex from the device that they're interacting with.
So can we roll the video?
Baby, I want to hold your hand. Baby.
The highlight was 45 minutes ago. I got to use a robotic arm for the first time, and I got to reach out and touch somebody for the first time in 7 years.
I can move it up and straight down and left and right and diagonally, and I can do a fist bump if you'd like.
That's amazing.
There's not a lot I can do from this position in my life physically, but now I'm doing so much. It overwhelms me. I'm so glad I did this.
Middle index and middle.
Oh my God, I just felt that roar. God, that is so cool.
That last clip is a gentleman named Doug who lost his lower arms in an industrial accident about 25 years ago. And that one's especially cool because he has a chip in his residual limb that is both controlling that virtual hand as he moves his arm, but it also is connected to the nerves that remain in. So we don't have to go into his brain directly. So that chip is just in the peripheral nervous system. But we now know how to send the precise neural signals that give him a sensation of touching that virtual door. And when you can see it in the physical world with an actual mechanical arm, but when you start thinking about the fact that you can do it in that virtual environment, I think it starts showing that beyond the phenomenal value of restoration of function, that also now starts opening a door to enhancement and to the ability for, through our brain, through our nervous system, just connect with the world in completely different ways. To sense in completely different ways. And we don't know where all that's going to go yet, but it's an interesting
So it's basically
threshold.
haptic feedback that goes through the nerves, and so that person is feeling it as if the biological arm was still in operation.
Yep,
Wow.
the signals that the chip is feeding into that nerve are the signals that he would have experienced 25 years earlier when his real fingers touched a door.
So it's not a question of having to translate sensations from a brain implant.
Right. The second to last one was that. That was what was going on there. In that case, that individual, Nathan, had implants on his sensory cortex. And so there we were sending signals from the mechanical arm directly into his brain. And then the last one was through the peripheral nervous system. So lots, and you learn completely new and different things every time you come at this from different directions.
We've pretty much been talking about hardware and software right now, but I was interested to find out that DARPA is involved in the wetware as well. For example, gene editing technology. And there's one sort of nightmare where Terminator and Skynet is going to take over the world. The other sort of nightmare is where genetic alterations go out of control. But sounds like DARPA has a plan for that.
Well, it's very much on our radar screen. And again, another classic double-edged technology. So on the good side, one of the programs that we've been working on builds on the amazing capability now to sequence and synthesize genetic sequences. And what we're trying to do here is we're asking a really sort of crazy question, which is, can you nip infectious disease in the bud? Right now, when we develop a vaccine, if you can do it at all, it comes usually way late after a disease has started burning itself out. And there's a lot of good incremental work to try to make that slightly better, but we want to do something that is radically different, that actually would completely nip these huge outbreaks that I think we're going to continue to live with. How do you completely nip them in the bud? So you have to do very different things for diagnostics, but part of how we think we can treat those very, very quickly has to do with finding the right antibodies in early survivors from that infectious disease, screening to find the ones that are actually dealing with that infection, and then finding ways to scale them very, very rapidly. And that's a very large, complex program, but just to cut to the chase, the first few performers in that program today are at the stage of doing development for Zika and Ebola treatments, which I think are super promising. It would be a radical departure if we could start to do that. So that's the kind of thing that becomes possible because of synthetic biology and gene, all of our abilities to synthesize and manipulate genes. But we also know that if you can do something that's that powerful to solve a hard problem. You can also do something powerful that would create some terrible problems.
So how do you roll back
right.
a version?
And so what we just started a program called Safe Genes. Maybe just to set the stage a little bit, I mean, you know, people talk about, it's so exciting to see what happens now with CRISPR-Cas9, right? This is the big revolution in gene editing, much more precise way to edit a genome. And it's taken the research community by storm. I think it's important also to say that when biologists tell you something is really precise, again, they're making a statistical statement. That means it's more precise than the thing they had before. It does not yet mean that it has the level of precision that's actually going to be necessary to do some of the really big, for example, people imagine using gene drives to have an economic way to engineer mosquito communities to prevent the spread of Zika, just as an example. You can't actually do that with gene drives today because our genetic editing technologies are not yet precise enough to accomplish those kinds of dreams. But they're coming. So this new Safe Genes program works on 3 questions. The first is, can we develop, CRISPR-Cas9 is awesome, but we think there's going to be a whole portfolio, and it's the beginning of a set of very precise gene editing technologies. We want to drive those and make sure that they're precise and controllable, and they don't do other things, they do what we want them to do. Secondly, we want treatments that when a genomic edit is moving out into the wild, if someone does that to us and we don't want it to happen, are there medical approaches that could stop that? And then third, are there ways that you could reverse, for example, a gene drive and return an environment to its natural state? So those are big, hard DARPA goals, and again, something we're just starting.
Huge.
But
well, I wanted to leave a couple of minutes for questions, but maybe if we can take a little minute talking about my favorite subject, space. Coming full circle. DARPA has a space program too, the XS-1 program for kind of reliable access to space. And it turns out that Boeing and Blue Origin, 2 of our favorite aerospace companies, were among the teams involved in XS-1, and we're about to go to phase 2. So is there anything you can tell us about what phase 2 is going to look like?
I can't because we're in the middle of sorting that out. But I can say, because I think what's happening with space, we're doing quite a lot in space, but space launch, we're right in the middle of this amazing advance that's happening, a revolution that's happening. And I think it's exciting to see. We think in terms of time to space, and what I think is happening commercially is a huge advance. Most of, the traditional way you go to space is years. It's billions of dollars in years before you can put the thing you have in your head on orbit and have it do something. These advances, like what was happening this morning, I think, these are all advances that are going to get us to time to space in months, perhaps, which would be an amazing advance. What this program, the XS-1 spaceplane program, is doing, we want to be able to put something on orbit tomorrow. And we need that for DoD because if you're going to have a robust space domain, we are so critically reliant on space for GPS, for communications. We can't function as a military without it. Frankly, we can't function as a society without it anymore. But in a time of conflict, it becomes a vulnerability. And one of the ways to offset that vulnerability is if we can restore our space capabilities tomorrow. It's not that exciting for the adversary to take something down on orbit. So we're excited about being able to go tomorrow, but of course that would be a phenomenal advance for all the commercial interests in space as well. And to do that requires not just doing your logistics smarter and better. You can't increment your way to going to space tomorrow. And that's what this program is about, is all the underlying technologies and the advances you would need to make space operations like aircraft operations. And in this program, we aspire to fly 10 times in 10 days as a demonstration that you just keep doing it daily.
And satellite servicing. I don't think we're going to have time to go into depth about that, but that's another thing that's part of the portfolio.
Yeah, and just a word on that is a lot of what's happening in space is about low Earth orbit, but GEO is a whole different ballgame, and the idea of being able to build infrastructure in this very long-lasting, high orbit that looks at half the world or a quarter of the world at a time, big opportunities there.
So I think we've got time for one question, so let's make it a really good one. You have a good question?
No pressure there.
No pressure.
Before I begin, I just want to point out I have the same last name as you. So
I'm sorry, I
Prabhakar.
couldn't hear.
He
Sorry.
has the same last name
I
as
have
you
the same
do.
last name,
I wonder if we're
Prabhakar.
related. I never meet anyone with my last
I know,
name.
me
It's
neither.
awesome
So I
to
have
meet
a
you.
special respect for you. But so the question is kind of related to that. Like, what is the one thing you do regularly or maybe every day that prepares you or gives you that futuristic vision that you need at DARPA?
You know, everyone is inspired in a different way. The thing that inspires me is talking to really smart, creative people. And so I try to refuel, first of all, by walking around in my building, because I've got 100 technical people who are there for 3 to 5 years, and they are amazing, interesting people. That always gives me a jolt. And I also try to get out in the world and talk to people. And I'll tell you, I had an amazing day here in Seattle yesterday. Every single conversation I had, left me reeling and thinking about what was going to be possible beyond that. So that's my personal way, is just to sit down and talk with people who are dreaming big dreams.
Let me wedge in one last question. I remember in The Graduate, someone comes up to Dustin Hoffman and says plastics. So what's your one word for the future technology?
4 years ago when I started, I would have said synthetic biology or that whole world. And I think that's going to be really awesome. There's another one coming that I'm starting to see. And that is, the most complex thing we ever try to understand is human beings and human behavior and societal behavior, right? I mean, I talk about complex. Everything else looks simple compared to that. And I think we are starting now in this world of big data, social, and the ways that people can interact. Those become lenses into understanding social behavior in a way that I think has the potential to revolutionize social sciences. And we're just starting to do some experiments in
so
that
social
world,
data analysis, perhaps.
Yeah.
Is that what you're going, where you're going?
I want to change, I want to tackle what are currently intractable problems in social science. And by the way, what matters more to national security than understanding social behavior? So I think it's a core thing for us, but again, something that matters for the world.
Okay, thank you so much, Arati.
Thanks for having me.
Let's give her a big round of applause.
Thank you.
It's
That
so
was
great.
I
Thank
enjoyed
you.
it very
Yes,
much. Thanks so much.